Hello again, a new day, a new project, and I want to test my antenna. I have something in my mind. You see this wrapping wire. I'm afraid it can turn to a coil. So before anything else, I just want to put some solder to each of them to shortcut any kind of coil effect, any kind of inductance. Well, I'm not sure, but I have to be clear about that. Something like this. It's not a big deal. Doesn't hurt the plastic or anything. So maybe the next project or the next antenna, I'll use some tubes instead of coaxial elements here. Anyway, it's an experiment and hopefully it will work okay. Let's check for short. Yes, we are good to go. So it's so funny. The tip of this is going down to the middle. Yes. Very nice. Okay, now let me find the proper connector. I'm gonna use my VNA to measure all the stuffs. I think it's RG174 and it have a lot of losing. I think it's like 60 decibel on 100 meters. Okay, we need a RP nail to get into this. I have to put this first. This is the tip. I'm not sure if I can just do it like this. Oh yes, I can, without soldering anything for now. Okay, I don't want to destroy this with solder yet, so I'm gonna do Cat 6 magic wire. This will keep everything in place. We got the tip very well positioned there. Okay, so somehow we are good to go. The instrument is already calibrated. Recall number 0, recall number 1. Okay, stimulus start from 850. Okay, let's make it bigger. 700 megahertz to 1000 megahertz. And let's see what's happening there. Whoa, it's looking like it's working. Look there. So we have like 107 on 943 megahertz. Let's get it even closer. Let's say 850 mega to 950. 944. What about my frequency? 889, 860, 868 that I have. So it's a little bit higher than I was expecting. What can I do? Funny. Let me try a trick. Let's improvise some capacitors. First of all, for the tip. But let me have some better division here. Display scale 0.5. Okay, so that's the frequency I want to improve, or the resonance I want to improve. If I'm going like this, and what do you think about this? 874, 103. Isn't this amazing? Just a few coils there. But what's happening if I'm just having the tip or the top a little bit longer? No, no. What about having the same trick somewhere in the middle? Okay, let me move this tip, make it a little bit longer. Okay, so I'm afraid the single way to do this is to fake a capacitor. And look here, 1, 2, 3, 4, 5, and maybe a little bit more. Oh, 881, look there. 103, that's a really good SVR. 105, 182, 866, I have 114. Okay, what about a little more? Okay, we got the best frequency here, 888. This acts like a capacitor, in fact. $9.26, not good. Let's go back. No. Not at all. Well, 878, 870, 888 with 007, and we have 906 with 003. Oh man. Oh, look here. 112, 009. Good. Let's the starting. Let's have 800 megahertz. 825. Okay, so the deepest it's going to this frequency here, 879. Almost there. 894, and I have another 105 here, 869, 104. That's pretty okay. 169. It's like tuning a guitar, you know. 102 on. Okay, that's it. That's the one. When I cut the wire, everything went differently. Let's put it up like that. In the air, everything changed. I'm afraid we need some longer elements. It feels like we need something like 120 millimeters. Okay, now piece of wire, frequency went down to 881, 142, 134. No, it's not a good idea. So I have to start everything from zero and to make this longer. Okay, but let me just have another segment here. Okay, that is good. The antenna was okay, good results, but in another band, 944 megahertz. It's not using me. I'm really sorry for that. So I have to some other longer elements, and that's because of the cable. Maybe I should check the cable first. The velocity factor of this cable, it's not 0.66, I think it's much more. I need to have longer elements in my case, and I should give another try. Okay, so I'm back with longer elements this time, 126 millimeters, and this is just an experiment. I'll do it in a proper way as soon as I found the right dimension. But this time I'm not wrapping any kind of wire anymore, so I'm just using the shield, the native shield I may say, from the cable, the cable's native shield. I don't want to make any extra effort this time, and I think we are good to go. The most important thing is to not have, or to don't make any short in between the elements. Yeah, it's okay. It's looking pretty okay. Let me check for short here. Where is my multimeter? Right here. Perfect. Perfect too. Okay. I'm wrapping this, and let me have the top. Yeah. And here, let me just connect the cable, or the feeding line. Good. So this is a collinear antenna with only 2 elements, so that should be like 3 dB gain. Let me have my nano VNA in place. Wow. Wow. Okay, so I recall number 1, 700 first, stop 1000 megahertz, of course. Now also display a scale 0.5. Okay, and look here, 880, a very nice and deep, I may say, on 880, 901, 123. Oh yeah, so I think this is much better. That's the way the things will run, to be sure that nothing else happening around. But look, this one, it's 880, and this is absolutely okay, pretty close with my needs. Of course I wish to have this one better, but I can do 880. Oh, that's okay, it's pretty okay. Nice. And this will go much easier because I don't do the, but you know something, I don't want to, I'm not doing the wrapping anymore, so it's just cutting the segments and connect them. So may I call this version number 3. I did that in less than 10 minutes with longer elements. So we have like 130 millimeters from shield to shield instead of 114. And now it's time to check the resonance. But first of all, let's see about short continuity. We are good. Top, it's perfect. Everything's fine here. And here too. No short, that means we are able to do the measurements. So, like I said before, I'm really suspecting the cables. You know, this kind of cables, they are the worst possible. But I couldn't find anything for now. I'm just experimenting. Let's see. Let's call. Number 1, display. Okay, stimulus start. 800 and okay, let's say 800 and stop to 1000. Oh, no, 800 mega and stop 1000 mega, of course. Then let's have a better scale, something like 0.5 and even better 0.2, please. And look here, people, I have 860 megahertz with 103. This is more than perfect. 886, 106, 108, 862. But this is really nice. I have a double gap there. So let's have it in the air somehow. 862, 104. This is the final result. I'll check for the gain, of course, but for now the working frequency, it's absolutely okay. 862. But that's very interesting gap here. You see, almost like a double on 870. You see, this is really nice. I love it. Let's go to a better, a larger scale. Start 700. Okay, mega. Stop 1000. And what we got here? 871. Well, it's working. Amazing. But with much more longer elements from shield to shield. Look here, like here. 129, almost 130. What I want to do now is to have some tape all around to keep the wires nice in place. Of course, I'm gonna have some shrinking tube. Yeah, good idea. Let me do that now. Oh, I think this is perfect. One. Oh, this is pretty okay like that. I don't want to destroy that. Nice. This is for keeping everything in place. All the wires. Do we have a change in frequency? No. Nice. So this is the final result. I did that in less than 15 minutes or something. And look there, we have on 862 a really nice CWR. So I may say this antenna will work properly. Let me have one at the end of the things there. And a little bit on the top, and we are good to go. And this will be installed tonight already with the elements around. Okay, it turns finally to 130 millimeters from shield to shield, and that was maybe because of the velocity factor of this cable. And I'll be back with some other projects. Don't forget to like, subscribe, and don't forget to have fun. Bye bye.